This video is going to introduce us to what we do before we build a model. So let me take us back for a second to this figure that I showed you on the very first day of class, which gives one version of a data mining process. And so where we've been spending most of our time so far has been this modeling box. And we're going to spend a lot more time in that box in the weeks ahead. What this week is going to be about is, well, we're going to talk about evaluation in some subsequent videos this week. So how do we evaluate a model? This video is going to focus on really these two boxes up here, which include data understanding and data preparation. So how do you go from a relational database or some other database to an N by P matrix, possibly with an output vector that you give to your modeling routine? So that's the main question that we're going to be addressing in this is how do we read in the data, and then how do we take multiple tables and reduce them to an N by P matrix that we can fit regressions on, or neural networks on, or cluster analyses on, whatever data mining model we want to use. So I'm not going to claim that there's a one-size-fits-all solution to reading in the data. Instead, it's a matter of running descriptive statistics and using them to see if you can trust variables. So that's really the goal with this is, understand what is this variable measuring? Can I trust the values that were read in? So I've got a nice case that we're going to discuss during class this week that's from a very dirty data set. You're going to be doing the second project in this course, which will give you practice in reading in data sets and creating variables. All right, so after you read in a table, you should just run descriptive statistics on every variable and ask yourself if the values make sense. So any categorical variable, you ought to be running a frequency distribution on. Really simple stuff from stat 1. I mentioned perhaps sorted in descending order of frequency. So this is a really useful thing to know what are the most frequent values for this. So if you had a variable that was state, where do most of the people live? So what are the most common values of state? Whenever you're running, whenever you have a numerical variable, what I'd, at a minimum, compute all the single number summaries on that variable. So what's the min, what's the max? Does the max make sense? If you had, for example, a 5-point Likert scale, hopefully no value exceeds 5. If so, something is wrong. Okay, so you want to just compute the basic summary statistics. One of my favorite functions for doing this is in the psych library, PSYCH. So psych library, there's a command called describe that gives you all of the single number summaries. So the min, the max, the mean, the median, the quartiles if you ask for them, standard deviation, skewness, all the basic descriptive statistics that you cover in that class. I'd also be looking at box plots, maybe histograms, to help me visualize the distributions. And then I always think about what would I expect this histogram to look like. Okay, so if it's a histogram of age, I'd expect it to be a little bit right skewed. If it's not right skewed, I start to wonder why. All right, so basically, do the values make sense? Counts and amounts can't take negative values. Likert scales on a 5-point scale can't go above 5, and so forth. Another thing that you may want to do is look at a correlation matrix and perhaps some crosstabs of categorical variables and see if what those crosstabs are showing or what the correlations are showing makes sense. So in the case that I'm going to give you this week, you're going to be running some crosstabs, and I'll give you a hint. Some of them should not make sense to you based on the understanding of the variables. So you're going to be practicing that today when we do that case. So the big question is, which variables can you trust? If you can't trust a variable, you need to go back to the source, person who gave you the data, and see if you can get clean data, or you have to find a way to work around it. The next thing that you're going to have to do is clean up the data. So whenever there are strings, you're probably going to want to standardize them. So for example, I had address data. Well, address data is notorious for these issues, but you can't imagine the number of different ways that people can write, for example, street. So you ask them for street, and some people put street, some people put ST periods, some people STR periods, some put capital S, capital T. And there's, when you run a frequency distribution of this, address, you can extract the street name, and you will just be amazed at how many different variations there are of this. You will most likely identify outliers, and then you're going to have to think through what you're going to do about those outliers. So what I always say is, number one, determine why the value is an outlier. And so sometimes you have an outlier because it's a mistake. Other times it's a correct but extreme value. So when you have a mistake, you want to either fix the mistake or set it to missing. When you have a correct but extreme value, you usually want to do something to reduce the influence on your models. So we had a whole unit on Cook's distance and all that back in regression. Logging often takes care of that, as do robust statistics, like using a trimmed mean or a median will also take care of that. You want to check all computed fields. So sometimes you're going to have a variable that was computed from other fields in the database. So it's not a good normalized database then, but it happens. And so you want to check that it was computed correctly. So one thing that could happen is the computed field hasn't been updated in a year, yet the rest of the variables that go into the computation are up to the minute. So then you would realize this computed field is not trustworthy. I need to recompute it myself from the raw data. Okay, so never trust a computed field. You always want to go check it yourself. You don't know, where does the code live that actually computed that field, and you probably won't know that. So another thing that I do, maybe I sometimes think I'm a little bit old-fashioned when I do this, but I try to reduce the file size. So I drop the variables that I'm not going to be using. Instead of having very long, strings that give me, say the entire state name, maybe I would reduce that to a much smaller variable using just 2-character abbreviation. That reduces the file size and speeds up processing. Now, I know computers are getting bigger, hard disks are getting bigger and all that, but I still like to have a pretty disciplined approach about keeping my file size under control. Another thing that you're probably going to run into is having multiple tables from a relational database. So you want to check your primary keys. Are they really unique? You also want to understand the relationships between the tables. So is this a one-to-many relationship, or is this a one-to-one relationship? And confirm that those relationships exist. All right. Finally, what I do is I create a file that has run the descriptives for every variable in the data set that I might use. So this is going to have a frequency distribution of at least the most common values for every categorical variable. It's going to have the single number summaries for every numeric variable. Maybe I have a box plot as well. And I save that. And that becomes a reference. So if I come back to this data set a couple weeks later, that's the first place I go. And sometimes I have these for decades. There are some data sets that I'm still analyzing from the 1990s, and I go back to my file of descriptives before I do anything with it. All right, where do we get data? Well, I'm just going to mention a number of sources and some terms that you should know. So you can get them through surveys or panels. There are a lot of companies like Nielsen or Ipsos that maintain a panel. So panel's a big group of people that are willing to take surveys, and you can pay Ipsos or Nielsen for access to that panel. Or Nielsen is another panel that measures TV viewership as an example. A few terms that you should know: third party, second party, and first party data. So third party data is data that you can buy from a firm that collects data. You pay them a fee and you get access to their variables. So for example, Axiom, Experian, Dun & Bradstreet are all companies that do this thing. So Dun & Bradstreet for B2B companies, Axiom and Experian for consumers. And so you can get things like credit scores, you can get demographics, you can get interest indicators and all sorts of things by buying this third-party data. What's first-party data? Well, first-party data is data about your customers, so it's data that you're gathering about your customers or your audience. Second-party data is data that is someone else's first-party data, and you either buy that data from them or you trade for it. So those are some terms that you should know. Another type of data is a behavioral log. Now, usually first-party data and second-party data are behavioral logs. So what is a behavioral log? Well, it's just a record of behaviors over time. And this is an extremely common type of data set that we have. So if you think about a transaction file at some retailer, so that transaction file would have a record of every transaction that every customer made. So you will know when was the transaction, what was the customer ID, what did they buy. So you have a time date stamp, price, quantity, and so forth. So that's a transaction history. Web log. So if you're say a company like ESPN, you know whenever someone visits your website, or if you're a retailer, you know when do people visit your website. You have a record of every click that they make on your website. Mobile data is another really good example of a behavioral log. So to keep things really simple, I've shown you the first 20-odd observations from a transaction history of a charity. So what you know is you have a customer ID, you have the amount of the donation, and you have the gift date. The source code indicates what the customer responded to, what mailing the customer responded to. So what you can see here is customer 18 made 2 donations, one of $10, one of $5, and you have the dates. Customer 935 gave you 3 donations of $100 each, and so forth. So this is a behavioral log. Now, we can't use the behavioral log directly in any of our models. So we can't just put this into a regression. We can't just cluster this. We have to do something to it before we can use it. So what do? Well, we aggregate it. So behavioral data in its raw form is not useful. We create what I call behavioral feature variables. So behavioral feature variables start by computing simple summaries of what's in this behavioral log. So maybe I count the number of records by customer. So that's a very important variable called frequency. Customer 18 will have a frequency of 2. Customer 935 has a frequency of 3, and customer 1347 has a frequency of 4. Another thing I may want to do is compute a sum. So the sum is called monetary value. So for example, the monetary value of customer 18 is $15. That's the total amount that customer has donated. The monetary value for customer 935 is $300, and so forth. Another thing I could do is find the minimum or the maximum. So for example, the minimum date would be the date of the first donation. The maximum date would be the date of the most recent donation. Then I could compute the time that has elapsed since, say, the first donation or the last donation. So the time since the last purchase is called recency. The time since the first purchase is called the time on file. So you'll notice that these simple summary variables are commonly available in aggregation software like SQL. So I could create these RFM plus time on file variables with a simple SQL query. So let's pull the ID. We're going to pull the minimum difference between, this is the date I'm studying. So this slide's a little bit old, but that's okay. The principle is the same. You put in today's date here. This is just how long has it been since that gift occurred. And we're going to take the minimum value of that, divide by 365 and a quarter. The quarter is for a leap year, to give us recency. We'll take the maximum value to give us time on file. We'll compute the count as frequency, the sum to give us monetary, and you will see that we get what I mapped out on the previous page when we were talking through this. So customer 18 has a frequency of 2, monetary of 15. We didn't do recency and frequency, but if you do the computation, you'll get those values. So let me go into a little bit more detail about these variables. So frequency and monetary are going to be usually very right skewed. They're both counts or amounts. So frequency is a count, monetary is an amount. So you will almost always want to log them to take care of the extreme skewness, which you have sparsity in the tail, and that destabilizes your predictive learning models. So little tricks like that will usually improve your predictive model a lot. Another really useful trick is to create variables from these things that you've rolled up. So one of the most useful variables in retailing or nonprofits is the average amount. So if you take monetary over frequency, you will get the average amount. So the average amount for customer 18 back here is, it looks like $7.50, whereas the average amount from customer 935 is $100. The average amount for this guy is probably a little bit less than $100. All right, so computing the average amount is usually a really powerful variable, because it says when this customer makes a donation, how much does the customer usually donate? Or when I make a purchase, what is the typical amount that I spend? And that usually tends to be a very important variable, better than monetary or frequency by themselves. Now, if I log both of these, notice that the difference between the logs just becomes the log of average order size. So including them separately implicitly captures the log of monetary over frequency. I'll just note that you often see a sign flip with frequency for that reason, because average order amount is a very powerful variable. So if you just had frequency in the model, you get a positive effect. If you include monetary, you get a negative, because it's implicitly capturing this ratio. Another really useful variable is the purchase rate. So if you take the frequency over how long the customer has been around, that is an indication of how often the customer buys or donates. You can do many more complicated summaries. So you could look for trends. Are my purchases becoming more recent, more frequent? Is my order size getting bigger? Is the amount of data that I'm using on the computer going up? Right, so those would be examples of trends. So you could discount some of these. So maybe a purchase that occurred 20 years ago is not as informative about what I'm interested in today as something that happened just yesterday. So you can discount this with a formula like this. All right. I'm now going to do a little case with you. This is a data mining contest that I organized more than 10 years ago now. And so we worked with a nonprofit organization, and this was taking place in 2005. So we didn't know the answer to the contest when we started it, which made it a very realistic competition. All right, so we gave people data from 2002 through 2006, and they had to predict what was going to happen in the last 2 years. So what I want us to do is to create RF&M variables as of September 1st, 2005, which is what all the contestants in this data mining competition had to do. Then I want to create another variable indicating how much they donated in the next, what would this be, year? So September 1st, 2005 through end of August 2006. And that's going to be our dependent variable. I want to merge these two data sets, and then we're going to go build a predictive model. So you could do this in a number of environments. So SQL would be a great one. My preferred environment is dplyr. A lot of people prefer data.table. So data.table and dplyr are kind of competitors. But I'm going to just illustrate one of these methods, namely dplyr. So if you don't know dplyr very well, go back to my interaction video, and I introduced dplyr in that video. So I'm going to read in the data. So we've read in our transaction data. We're not going to make use of the source variable for this exercise, so let's just get rid of it. So if I set the variable to null, that deletes it from the data frame. Then I'm going to compute the time between the time of the mailing. So let's just pretend that today is September 1st, 2005. So how long has it been since this transaction occurred? So we're going to take September 1st, 2005 minus the transaction, divide by the year, and you end up with the time since the transaction occurred. So let's just go take a look at what we've done. So you're going to see this first customer only donated once. These three are all kind of boring. Then we have a customer who's given to us 5 times. 4 of those donations took place before September 1st, 2009. This one has a negative value. That last record is a future donation. So that's like saying, on December 27th, this customer gave us some money, $100 it looks like, and that occurred after this, which means it's in the future. That's going to make up our dependent variable. So we're going to want to predict all the transactions that occurred after September 1st, and we'll do that just by looking for negative values of t. All right. This other customer looks like also gave 5 times with 1 donation in the future. So let me now show what we want to get to, which is just an RFM data set as of September 1st, 2009. So the thing I want to mention is with this customer, whatever that is, 546, notice the frequency is 4. We're not counting the transaction that occurs in the future. That's going to make our dependent variable. Likewise, with this customer 641, we have 4 transactions, not 5. All right, so how do we do this? Well, let's use dplyr. I decided to do everything in dplyr. So, let's read the data in, and then I'm going to use a mutate statement to create some new variables. So let's convert the gift date string variable into a date type variable. So this is going to be a numeric variable that we can do computations on, like computing a difference. very important to us. I don't have the data. It wasn't in the standard format, so we have to specify a string. So this means it's going to be in the format month, month, day, day, and then year, 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 year. There's going to be 4 digits for year. Then we can also compute the time since that purchase. This is almost an exact copy of what I had on the previous slide, but just wanted to show you how you could do that in a mutate statement. We could keep only the variables that we need. I think it's always a good practice to not keep extra stuff that you're not going to use. So I kept only the variables I needed, or I could have dropped gift date and source with a minus command. All right, let's go make our RFM data set. So we're going to create an object which is RFM. Where does that object come from? Well, I'm going to take the transaction file that I just read in here, and we're going to pipe this to filter. We're only going to keep records where t is greater than 0, meaning this happened in the past. We'll group by ID. You can see how much this looks like SQL, or SQL even calls it group by also. And then we'll use a summarize command. The author of the dplyr package is from New Zealand, and so he spells summarize with an S rather than a Z. I think it accepts a Z also. So I've gone off, I've computed frequency as the count, monetary is the sum, average order size is the amount, so I'm just computing that mean all at once. The date of the last purchase is going to be the minimum value of t, which will be recency. All right. Next, let's go create the dependent variable. So how do I do that? So now we're going to take only values where t is less than 0. We'll group by the ID again, and then we'll count the number of donations in the future as well as total their amounts. So we could have 2 dependent variables if we want. Now I have to join these I need to join these 2 tables. So dplyr offers a full set of joins. You get a left join, right join, inner join, outer join, a whole set of joins. We'll do a left join on this because I want to keep all the records that are in the RFM data set. Many of those in the RFM data set do not have a record in the dependent variable data set, and so that's why I want a left join, because there's going to be a whole lot of missing values. That means people that did not donate in the future. All right. So we'll just pipe this into a mutate statement. And so anytime there's a missing value in the dependent variable, so if targ freak is missing, then I'm going to assign it value 0, because missing in this case means you didn't donate, therefore you had 0 donations. We'll do the same thing for target dollars. We can look at the data. Always a good idea to do that. I would check a couple records by hand, and we end up with basically what I had here, but this version of the RFM data set had not been joined with the target data, with the dependent variables. So you'll see I've added those dependent variables. Now we could go off and build some predictive model. I did a regression just for a quick and dirty model. All right. Now, a couple more things I want to go over with you. Sometimes you'll have what I like to call taxonomy metadata. So if it's a retailer, maybe you know what product category each purchase came from. Or if it's a credit card data set, you would know the type of merchant. Is this a gas station? Is this a grocery store? Is this a retailer? Or is this your cell phone bill? So you'd have all these different types of merchants. If it's a TV viewing data, I would know all sorts of, what genre are you watching? What subcategory are you watching? Is this a Cubs game versus a Sox game? And so forth. So this data, metadata like this is ubiquitous across, every category I can think of. So there's a couple things that you might want to do whenever you've got this taxonomy metadata. The first is you could compute simple summaries, so like frequency and monetary, by customer and type. So for every customer, how many times have I bought bananas versus meat versus canned goods, if this is a grocery retailer? How much have I spent on produce versus meat? Another thing you can do is look at a customer's scope. Scope is going to be the distinct number of types. So how many different categories am I buying from? So if it's a grocery retailer, am I only buying from a narrow set of categories, or do I buy all my groceries from you? I'm not buying from anywhere else. Well, you'd be able to capture that by computing scope. So that's just another good variable to count. So often the trick to a good predictive model is creating the right feature variables. Entropy is another one. I'm not going to spend time on this video talking about entropy. So how do I compute frequency and monetary by type? So I thought I would rig up a very small example that would illustrate this for you. So I've made myself a miniature transaction file. So what you're going to see is I have 3 customers, customers 1, 2, and 3. Then we have various purchases. Let's forget about dates for now. And so I know the amount that they spent, and then I know what category these purchases are from. So customer 1 seems to like category A a lot, and category B a little bit. On the other hand, customer 2 only buys from category B, not interested in category A at all. While customer 3, you're going to see mostly likes B, but occasionally buys A. So what I'd like to get to is a count of how many times each one of these customers have bought from categories A and B. So you can see this is what I want to get to. So customer 1 has bought 3 times from A, once from B, and so forth. So how do we do that? Well, the answer is we're going to use dplyr. So I'm going to, if I send dat, we'll group by ID and category now, and then pipe that into a summarize command where I count the number of purchases. And so now you see that customer 1 has bought 3 times from A, once from B, and so forth. So we're almost at what we need, but I need to transpose the frequency and use this category as a label, because I want it to look like this. That's something I can throw into a regression. So how do I do that? The answer is I'm going to use a command called spread. So spread is in a different library that's part of the tidyverse. So dplyr is one of these commands. Tidyr is another library. They're all part of the tidyverse, along with things like ggplot. So all I have to do is take this command that I wrote before and add a spread. So let's pipe it to spread. I'm going to spread across categories the value of f. That's the way to think about this. And you're going to see that we're almost there. Now, the reason I say we're almost there is I've got an NA, and I don't want an NA there. That NA is because customer 2 has never bought from A. That NA should really be a 0. So there's actually an option that we can give to spread, which is fill equals 0. So if you don't have a match, just fill it with the value 0, and we get exactly what we want. All right, so that's it for my lecture on creating variables. So reading in data and creating new variables. You're going to be practicing this on the second project that we're doing in the class.